Hi everyone, welcome back to my channel. Now this video is basically a continuation of the previous video where we talk about AAA and introduce the topic. Here we talk about authentication majorly and talk about how are people authenticating themselves, how are systems authenticating themselves, and then we would look at visual step-by-step diagram on authenticating systems. We would also talk about authorization models a little bit more over here, but it's just an introduction to get an idea of what they are basically, and then we would look at different authorization models in detail later on in another video. So let's just dive right into these topics and understand what they are. So let's talk about how do people authenticate themselves. So there are things like username, your password, your pins, your passphrases. All of these combined, they make up into something that you know of. So you know of your username, you know of your password, you know of your PIN, and so on. And then there come smart card tokens or security tokens, and these are something that you have because they are installed in your mobile phones or your laptops, etc. And then there comes biometric IDs like your fingerprints or your face recognition. So these are something that you already are. So all of them combined, they make up as a multi-factor authentication, so MFA. So for example, when you want to log into your bank account or any account per se, you use your username and password, so that is something that you know of, and then you get your OTP and as a security token. So you enter your OTP, so that is something that you have, and that's MFA in action for you. So next up we have authenticating systems. So just like people, systems also need to authenticate themselves. They also need to prove their identity so that they can talk to each other, and so that the connection is secure and they can also exchange the data securely. So there are some ways to do it, and the first one is digital certificates. So let's say you have a website and it does not have a digital certificate, and you try accessing that website. Now it will show an error saying that the connection is not secure, and are you sure you want to proceed there? So what does that mean? That it does not have a digital certificate, which means it is not trusted by an authority. So if you see such websites, then that's a giveaway that the website could be a scam or it could be a fraudulent website. And that's how you make sure that the data is secure and your connection is secure. So next up we have shared secret keys. So what does this mean? So you have two secret keys that are that needs to be installed within the system so that they can talk to each other and they can create a connection. For example, you have a router and the router has its secret key installed within it. So when you try to make a connection with the router, you also need to install the secret key within your system so that they can then talk to each other and then they can exchange the data with each other. Then we have cryptographic keys. So for cryptographic keys, we need two components. We need public key and we need a private key. What do I mean here is that you sign something with a public key and then you decrypt it using a private key. For example, you send an email to a person. Let's say you send a confidential email to a friend. So if I send my an email to my friend, then I would encrypt it using her public key and send to her, and she would then decrypt it using her private key, and then she would be able to read the message that I sent to her. So if in between somebody else gets that message, then they won't be able to decrypt it because they do not have the private key of my friend. So that's how we make sure that the data is secure while I'm transferring an email from me to my friend. Now next up we have protected access files. So similarly, these are files that have credentials stored inside of them. So when a server tries to make a connection, it checks for the credentials inside of those files and see if those credentials are true or not. And that's how systems authenticate themselves, and then they can exchange the data securely with each other. So now let's look at a visual step-by-step diagram and see how does authentication takes place when you try to log into a system. So you have a user and then it sends a request, or it sends data to a server. Now that server will send a request to a database. Now what is this data and what is this request that is going into the database? So the user is sending its credentials so that it can log into a system. So the server is checking if the database has those credentials or not. So the database sends the stored user password for the username, and the server then checks if the password that the user gave matches with the password that is there in the database or not. So if the password matches, then it sends a auth token to the user, and if it does not match, then it sends an error response to the user. So finally, we have authorization models. So by now we know what is authorization and how does it take place. Similarly, we have authorization models. So for example, you are a user and you want to access an application. So your authorization model is only going to depend on one thing, which is what kind of a user you are. So when that's decided, you can access an application. For example, if your role is of an employee, then you can access the portal for approving house loan. Similarly, if your role is of a customer, so if you're a user who is a bank customer, then you can have the access for checking your bank account, and that's how authorization model works. So I hope now you know how people authenticate themselves, how are systems authenticating themselves, how does authentication happen, and what are authorization models. So I would like to really thank you for your support, and keep watching, keep subscribing, and see you in the next video.